Good morning, engineers. It's Mr. Heller with your work for the week. Today we're going to be looking at an idea of work done. This leads us directly from last week's work on energy, and in particular we're going to be looking at some energy changes today. You'll remember from your GCSE physics or physics this year that energy can't really be created or destroyed. It can only be changed from one form to another. And what we call that change of energy from one form to another is work done. So we're going to be looking at three kinds of work done today. One of them is work done against some sort of general force, which might be friction, for example. Another one is work done against gravity, where we're lifting an object through a height. And the third one is work done by accelerating an object from one speed to another. Okay, so we're going to link that in, possibly into our SUVAT formulas as well. Right, so let's have a look at this first example here. It says an airplane is pushed down the runway for 250 meters with a force of 200,000 newtons. What work is done? Okay, so in this case, I'm going to look in my formula booklet. I've got this one here. It says mechanical work, W equals Fs. Now we might be tempted to think that S stands for seconds, but that's S, like in our SUVAT equation. That means the distance. So I'm just going to make a note of that. So that's going to be the force times distance, and of course that distance is going to be measured in meters. Okay, so let's have a look. An airplane is pushed down the runway, 250 meters, force of 200,000 newtons. So our work is literally just F times 200,000, and that's going to come out as 50 million. Let me just check I've got the right number of noughts. Joules, or 50 megajoules. So don't forget, use of standard form might be needed here as well. We could say 50 times 10 to the 6 joules for engineering form, or 5 times 10 to the 7 joules. All of these forms are equivalent and obviously acceptable. Okay, next question. A component of mass 40 kilograms is raised through 230 millimeters. So that might be being jacked up or lifted by some crane or winch, doesn't really matter. But what we're asked is what work is done. And the first thing here to realize is that I'm obviously going to change that to 0.23 meters. Now, gravitational potential energy, we know from last week, is m mass times g, this acceleration due to gravity, times the height. And because this mg is a force and that's a distance, it's literally just the work done is going to be the mass times g times the height, 0.23, and that's going to be 90.252 joules. And what tripped some of you up last week was not rounding that to three significant figures. 2 or 3 significant figures are usually acceptable in the mark scheme, but I'm going to say always go for 3 significant figures, 90.3 joules there. Okay, so that's an example where we said that W equals mgh. Okay, final one where something changes speed. I'm going to say that the work done is going to be half mv squared minus half mu squared, where if you remember from SUVAT, we had v being the final velocity and u being the initial velocity. So if I just substitute my numbers in here, I'm going to say half times 350, that's my mass, times 8 squared minus half times 350 times 6 squared. That's going to come out, I want to do my substitution in first of all, that's 4,900 joules, or I could say 4.9 kilojoules in that case, remembering that 1,000 joules is a kilojoule. So what we've seen is we can express work done in 3 ways. Work done against some sort of general force, might be friction that we're overcoming, might be air resistance, don't know, doesn't really matter in this case. We've done work against gravity by raising it through a height, and then we've done work to accelerate an object. Okay, so the exam question that I've given you uses 2 of these. The worked examples that I've given you here use all 3, and in fact the examples with solutions that I've sent you use all 3 types of questions as well. So good luck with that. Look forward to seeing it. As always, don't forget to email me if you've got any questions.